1.3 Day 6 Measuring Angles. I want to be able to name and classify angles and then measure angles and angle bisectors. It's a decent amount of notes. We will work through some problems, but first we got to get rid of, or get out of the way, some of these definitions and this vocab. So, an angle. You probably have heard it. It's a figure formed by, I know you've heard this, two rays with a common endpoint called the vertex. Okay, plural, don't say vertexes, you would say vertices. Okay, the measure of an angle is given in, and again, you probably know this one, it's measured in degrees. So, if we look at this angle over here, there's a couple different ways we can name it. First, we want to make sure we know what the vertex is. The vertex is this point A, where everything comes together. Okay, everything's based off that vertex. Two rays make up the sides of the angle. Okay, you can think of them as sides. They are rays AR and rays AC. Make sure you're labeling your rays correctly. Okay, here's one way you can name an angle. Name a point on each side and the vertex. The vertex is always, always, always in the middle. So we could say it's naming it by angle RAC, or you could go backwards and go CAR. You can name just the vertex. Now, it can only be done in some cases, and I'll show you one that doesn't work. So we would say that this is angle A, and then by the given number, if there's a number in there, you could call it angle. Let's make sure that looks like a 1. Okay. Here's where it wouldn't work, by naming it just with one letter. You have angle, this entire set of angles really, and you want to refer to one of them as angle A. Well, if you tell me angle A, are you talking about this angle, BAC? Are you talking about this angle, CAD? Are you talking about the whole thing? Oops, the whole thing here. Moving the camera. You're talking about this whole thing. So you don't know which one we're referring to if we say, yes, it's angle A. So you cannot do it because there's more than one angle. So make sure if you get something like that, you don't label it as angle A. I don't know what you're talking about if you say angle A. I know what picture you're looking at, just not what angle you're referring to. So the three angles pictured would be angle BAC, angle CAD, and the big angle, angle BAD bad. Okay. A couple other types of angles. Again, these are things that you've probably seen. An acute angle, think of the word acute in there. It's less than 90. It's greater than 0, but less than 90. It's small, it's acute. Right angle, it's like driving down the street, making a right turn. It's exactly 90 degrees. Anytime you see this box, it's 90 degrees. Now, if you're given something like this, and it looks like 90, don't assume it's 90. You cannot assume. Make sure you see that little box there, or we tell you it's 90. Obtuse angle. Think about the word obtuse. As it comes out, it sounds like it's big. It sounds like it's something bigger than acute. It's bigger than 90, and it's less than 180. And you have a straight angle, two opposite rays. Straight angle, pretty simple. It's a straight line. Now, easy way to remember this is you're walking one way. Say you're walking this way, and you want to turn around the other way and go the other way. You're doing a 180. For those of you that are into sports like me with wakeboarding or skateboarding, you would think of a 180 as a half turn. You'd go back and turn the other way. Okay. Interior versus exterior angles. Okay, again, not too bad, pretty simple. The set of all points inside the rays of the angle is called the interior of an angle. Inside, interior. So the exterior of an angle is the set of all points outside the angles. Okay? What happens when we create a ray RQ? Well, we just created another set of angles inside. That's all that's happening. So you create another angle. Alright, now for some postulates and then some practice with some actual mathematics involved here. Angle addition postulate. If R is in the interior of PQS, then PQR plus RQS equals PQS. If the measure of PQR plus RQS equals PQS, then R isn't in the interior of PQS. Or we could go simple and say, okay, little angle plus little angle equals big angle, just like with segments. So, angle 1 plus angle 2, those two slices add up to the entire slice here. Pretty simple. So we'll call it little angle plus little angle equals big angle. So if we're given an example, starting off pretty easy, what is the measure of angle PQR if PQS, so this entire angle is 78 degrees, and RQS, make sure you're able to follow how you label angles, is 46 degrees. Well, we have little plus little equals big. Okay, well we have one of the littles is not 76, is 46. Plus, we don't know the other little one, we want to find it, equals the big. So we'll say 46 plus, we're not going to keep calling it little, we'll call it x equals 78. Subtract 46 from both sides, x equals 32 degrees. Therefore, measure of angle PQR equals 32 degrees. Okay, not bad. You probably in your head just did 78 minus 46, which is just fine. Now, you won't always be able to do it in your head, especially when we add some algebra in here with some x's, other variables. So look at another example. In this first one, always label what you're given, especially in geometry. I'm going to remind you to do it all year long. EBD is 5x plus 10. Do not automatically assume that's a right angle. We don't know that. It could be, maybe, maybe not. We'll find out. DBC is 6x plus 8. And EBC is 150 degrees. Okay? Find x, then find EBD. Geometry, you always have to find x, then you can use it to find other pieces that we might use. So, we know that this little piece plus this angle, so these two angles together add up to the big angle. So, it's going to be your little plus your little equals your big, or 5x plus 10 plus 6x plus 8 equals 150. Now it's your algebra. Okay, combine like terms and solve for x. So we have 11x equals 132. So that's going to give me, divide both sides by 11, x is going to be 12. There's x, half my answer, but I've done most of the work. To find angle EBD, we would go ahead and look at that here. Find this angle, simply take 5x plus 10 and plug in that x. So we have 60 plus 10 equals 70 degrees. Okay, and that would be angle EBD. So measure of angle EBD is 70 degrees. Always find x, then use it to find something else. If you want, go ahead, try part 2, see what you can do. There's a little hint there to help you out. See if you can solve it. If you can, good. If you can't, keep watching. I'll solve it with you. If you can, go ahead and see if you come back and get your correct answer. So, label it differently this time. ABF is x minus 1. FBC is 8x plus 1, so where's FBC? So from here to there is 8x plus 1. If you want to label it differently, again, that's fine. So, we want to find x, then find FBC. Alright, well, how are we going to do this? Hint, what type of angle do ABF and FBC form? In other words, what's this whole angle from here to here? Well, if you look at this, it's actually a straight angle. Scroll right back up real quick. A straight angle measures 180 degrees. So we know that ABF plus FBC add up to 180. So we're going to say x minus 1, there's one little angle, plus 8x plus 1, there's my other little angle, equals the big angle, 180. So combine like terms, negative 1, positive 1 cancel, divided by 9, x equals, you can do this without your calculator, don't look at the 0 here, okay, make it 18 divided by 9 is 2, then add on the 0, x is 20. Now we can go ahead and find FBC, measure of angle FBC was equal to 8x plus 1, so we'll just go ahead and plug in 20, so that's 160 plus 1, 161 degrees. Okay, so not too bad at all. An angle bisector, same idea. It's going to cut some of these angles into parts. Bi meaning two, sector, so it's two sections or two parts. So we'll say it is a ray that divides an angle into two congruent parts. You'll see that symbol a lot, so get used to seeing it. It just means instead of equal, it's congruent. It's essentially the same thing, just with geometry. Excuse me. Congruent angles, angles that have the same measure. Okay. Congruent arcs are used to show that angles are congruent. In other words, this is what you'll see. If you see two angles that are marked with the same arc or the same number of arcs, all that means is they're congruent. So x and y are congruent. That's all that's saying. It's very simple. You could, if you wanted to, make it two arcs. You'll see that sometimes. As long as they have the same notation, that means they are congruent. So looking at a couple of examples, there's a bunch on here. Example 4, BD bisects ABC. Right off the bat, that tells you it's cutting it into two equal parts. That was a bad arc. Let's erase that. Okay, measure that. I wouldn't put one big arc because it's going to look like just one big arc. Make it two separate ones so you know that those two angles are congruent. ABD is 6x plus 3, DBC is 8x minus 7. Find x and then find ABD. Okay, not too bad at all. We know that in this case both those angles are congruent, so 6x plus 3 is equal to or congruent to 8x minus 7. Solve using your algebra. So we have 3 equals 2x minus 7. And we get x to be 5. There's x, part of my answer. ABD now, go ahead and plug it in. So measure angle ABD is equal to 6x plus 3. Plug in your x that we just found, and we'll find the measure of angle, ABD to be 33 degrees. Okay, and then you're done with that. So again, it just means it's cutting it in half so that you have all of a sudden now have two equal parts. Alright, let's see if we can find example 5, get through that one, and then maybe have you work on 6 and 7 tomorrow in your group. So, example 5, BD bisects angle ABC. Again, as soon as you hear that, cut this in half. Show me that there's two equal parts there, two equal angles. ABD is 5x plus 24, and DBC is 15x minus 6. Again, this is not too bad at all. Find ABC. Okay, we will in a second. First, we know that 5x plus 24, that angle has to be equal to 15x minus 6. They're two equal angles. subtract 5x, and you can probably do the rest. Fast forward, or pause and then work ahead if you want to. See if you get the right answer. So we get x is 3. We want to find ABC. Okay, well if we can find either this angle or this angle and double it, that's fine. You could add them up, then plug in x. It really depends on how you want to do it. I'm going to go ahead and find DBC, so 15x minus 6. So it's 15 times 3 minus 6, 45 minus 6 equals 39 degrees. Oops, I don't want to circle that because that's not our final answer. Whoops. I'm on the wrong page now. Bear with me 1 second. There we go. Okay. Don't hit the wrong buttons. We don't want that. We want just 39 is DBC. Therefore, this is 39. So the measure of angle ABC is then 78. Just double it and get your full angle. I want you guys to try 6. You're going to have to factor, which we did all for 1 week in algebra review in example 6. You can go ahead and try example 6 and work ahead, and then we will work on example 7 tomorrow in class. So try example 6, see if you can get it, and then example 7 we will do tomorrow in your groups.